model space. The last one is model registry. This is basically to record. In short, it is a repository where you're recording what is the best model. Store, annotate, and manage models in a centralized repository. Because when we talk about development, you will have different developments. We don't know which one is basically the latest one or which one to be deployed and all that. So we will be able to define what is the best model that I want to deploy. You select a model and declare that it is deployable. So every team member that is using will know that, okay, this is the final model which I need to use for deployment. It could be a different team member also. If you have a UI provider, then they will be able to select. Right? So that's basically how your model registry works. It internally also takes care of CI/CD tools. It can incorporate with any CI/CD tools, or if you design your code in such a way that it is retraining, you can also use the same thing for your CI/CD implementation. Right? And it is a centralized repository control, which basically allows you to have the control over the executions on different models. You can see you have different versions. The stages are there. This is archive, this is staging, this is production. So version 3 is the model which is best model that needs to be put in the production environment. The remaining experiments are only experiments. They are not to be deployed. So you will be able to see this, right? All this comparison can be done. So register model, get the registered URI, or you can set it so that you can try and register that, or I mean, push that for your serving mode. These are all the commands for creating your models and all that. I mean, versions, specific versions. Okay. And everything is readily available in the artifacts and meta store. You can see it's there. All you do is load model, that's all, and give the artifact or the URI, model URI, which you define as the best model, and it takes all the details from that particular folder, and then it pushes. MLFlow helps you to push your best model into your production. Okay, so yeah, let's move on. There's not much of theory here. It is very high level theory. Now, in order to do this, everybody is using Anaconda. You are using Python, which is managed by Anaconda only.
Yeah.
Okay. So open Anaconda, and I will show how to create a new environment. You can use virtual environment if you are comfortable with that. Use virtual environment and proceed. But if you are not sure about the virtual environments and all that, then we can try and use the Anaconda platform to create another complete environment. Physically, it is going to get created. Within that environment, we will be installing MLFlow. So open Anaconda, Navigator. And here, if you see towards the left side, you see Environments tab. You click on that Environments tab. Once you click on the Environments tab, at the bottom, you will see Create, Clone, Import, right? These options. By default, you will have Base Root. This is the only option you will have by default when you are installing Anaconda. This is the environment that you're using. But you can create as many environments as you wish. That means separate Python software gets installed, and Anaconda will allow you to manage those different Python instances. So I've created, I'll say create, click on create button. It will give you a pop-up like this. You can give name. I've used MLOPS. And then you can see Python, packages Python. It is checked. Under the Python, you have different versions. Don't go to the latest version. Choose 3815. I've not tested in 3.9, so I don't recommend that, but it should be supported. 3.10, that is 3.10, is something that I'm not sure of. I don't think it will work there, the latest of the versions. So my recommendation would be 3.8. Choose that version, right? And then you can say create. Right? It will give you this create option. You can see within Anaconda folder, there is another environment that is getting created. Okay, once you click submit, create, you will get this folder like that, this name like this pop-up. Do it. It is going to take a little while. Once this is created, you click on, right? Once this is ready, you can go back to home. Under the home, you can see all applications on. The drop down shows base root. I select MLOPS. So we are now trying to use the applications which are pinned with MLOPS. Here, you can try and install Spider. It will first say install Spider, and then we will be able to launch it. So create an environment and then come to the applications of RAN on top of that environment and use Spider, launch it, install it and launch it. It will take some time. Just initiate it and you can then go for the break. We'll take a 10 minutes break and we'll come back at 10:55. It's 10:46 now. We'll take 10 minutes break and then come at 10:56. Yeah. Okay, so here we go to must stop it. We go to MLFlow. And yeah, these are all the different. Okay, model registry should be there. Fine. MLFlow, ML project demo Python code. Let me see what is this. And okay, this is for your DBC file is for the Databricks. So we'll download the data. So MLFlow, ML project demo Python code, and then datasets. Download these two first, 1 and 2. And this is what you get. Wind example.py. Once you unzip them, you'll get this. Yeah. Download it. You open this wine_example.py file in your Spider, which you have launched from this new environment. You have created a new environment. You come here. You ensure that all the applications on that new environment is selected. Install Spider and launch it. I'll show the code. I'll walk you through the code and then we will execute it. Very simple. It's I mean your regular ML code. So I'm importing all the libraries that are required. MLFlow. This is the package. Of course, we'll have to install it. I'll show how to install it, or otherwise we will try and install it and then come back to the discussion. Okay, come here to the Anaconda navigator. Select the environments once again. Right, come here to the environments and select your model and the environment that you have selected. You see this green button. Left click, don't do right click, do left click only. And you will see open terminal. Do this. Open the terminal, it will open your command prompt. This command prompt should show that it is associated to this environment. Because when you do pip install, This pip install command should be applied onto this environment, not to the base root. So don't go to the command prompt directly from Windows. Open the command prompt from Anaconda Navigator environments page. Left click on this green button and then open the terminal. All you are doing is pip install MLFlow. That's all. You just say pip install MLFlow. Run it. It will take time, but run it. Once you have started, you can come back here to the code and I'll explain the code. So we are loading all the libraries that are required, including the MLFlow library. MLFlow sklearn, because that is the model that we are going to run now. In order to capture the metrics, we are writing custom function so that I can pass the actual values and the predicted values. And I will be able to
one second. Where is this wine example.py?
It's there in the LMS. In the LMS, you will have MLFlow topics. Here you will have one data set and then this code. Got it?
Is it under MLFlow underscore ML
Topics.
project underscore demo.ipy?
Yes, yes. This
Okay.
one, yes.
I mean, that
You
is same as
unzip
the Python file that you were explaining, right?
Yeah, it is the same thing. If I unzip this,
because it named differently, so that's why I was.
it is in IPython notebook. You can open Jupyter. Okay, let's do one thing. Open Jupyter here under the environment. You see Jupyter notebook, right? You can just launch Jupyter notebook and open that. I thought it was a Python file, so nevertheless, let me just try upload here. Where is this file? I just uploaded it. Yeah. Oh, this is a different code, huh? Why is this code not updated? Oops. Wine quality, let me see wine quality. Great. Okay. The code is not shared. I'll share it. Let me share this code with you people. The IPython notebook is a different notebook altogether. Let's not do that. That's okay. You can ignore this. Good that you have brought this to the notice. I'll get this shared right away now with you people over WhatsApp. You can download it from WhatsApp, and I will get it updated into the LMS. There's other code also which was recently updated. I'll share that code as
well. You can't share through chat here in this.
Sometimes it doesn't work. So WhatsApp is a better option.
Okay.
Sometimes it works, sometimes it doesn't work. Right? So, don't know. I'll share it there also. It's not an issue. I'll just put that here. Dataset you anyways have. This is the code. This is the first code. I shared it in the WhatsApp. Let me put it here also in the files. Where is this file? File from here. Not this. Yeah, I've shared in the Zoom as well. I get this updated to your LMS. Okay? The old stuff I'll get that removed and new stuff will be added. Open this file.
Yeah, sure. Yeah, I was able to open in Spider.
Yeah, it's a Spider file. Yes, please open that in Spider itself. I hope you have started the MLFlow installation here. Pip install MLFlow command is already executed, I'm assuming.
Yeah, that's done.
Okay, perfect. Okay, so let me explain the code. So we are basically trying to load the data. Import sys is not required if you are doing it on the Jupyter or Docker or right these things. It can be ignored. The other functions are important. We will be loading them. This line number 10, import MLFlow, if it fails when you are importing it, then restart the kernel. Okay, you can restart the kernel by going to the console page here and just say restart kernel, control plus dot, this symbol. It will automatically restart the kernel and then you will be able to load all these libraries once again. Okay, now post this, I'm defining the metrics for our regular machine learning models. Here, I'm trying to set experiment. When I say set experiment, I'm creating a new experiment with this name. So what happens is this will be like a execution that we are trying to define. And MLFlow will be able to track the execution as an experiment. Then we are moving ahead into the regular ML code. So this code is getting wrapped using this main function. Within that, we are writing your experiment details. Okay, so once the data is loaded within this, we will partition the data. We basically try and split it into input output. These are the parameters that we are going to pass for our model. The linear regression model I'm using is ElasticNet model here. So once these parameters are defined, we can come here and start the run. So define the experiment, and within the experiment, if you want to run the code, you want to, that is training jobs, right? If you are to train the job, you will be able to train the job using different parameter set, hyperparameter set. The hyperparameter set are defined here, right? So float, take the system arguments. If the arguments is greater than 1, then use it. Otherwise, choose default 0.5 or 0.6. All right, so that's the arguments that we are passing. And then we are trying to train the model, then use the model to predict on test data set. Then we are going to call the eval metrics, this custom function that we defined here, which will capture RMSE, mean absolute error, and then R squared values. Right, so these are the three things that it captures: root mean square error, mean absolute error, and then R squared. These three metrics are captured here for different alpha and different L1 ratio. Then we are also trying to capture these things in MLFlow. Till here, we are only recording or calculating the metrics by passing the different parameters. But here we are trying to capture these details. So log underscore parameters means it captures the parameters. These are the three parameters that we are capturing: the data partitioning size, the alpha value, the L1 ratio value. Then we have RMSE metrics. These are metrics that we are capturing: RMSE, R squared, and MAE. We are also trying to log the model. So whatever is the best model that we have got here, which is LR, I'm trying to save that as model. That's all. So this is the custom function that we are running.